It is truly an honor for me to be here today for many reasons, not least of which is because a number of Swiss companies have been very important instructors to me, teachers to me, about how innovation and how innovative manufacturing can happen, not just in China and not just in Asia, but really in a global setting. I thought I would offer a few ideas and speak for maybe 20 minutes or so, but please feel free to interrupt at any time. If you have a different view or a question, don't hesitate to interrupt, and I don't plan to go on for too long. So just beginning with the title, The End of Cheap China, I don't think there's really a need to put a question mark after that. I think everybody recognizes that China is no longer the cheapest place in the world to do low-end manufacturing. I don't need to put up slides with data, but wages have clearly gone up at the bottom of the labor spectrum. Wages have clearly gone up at the top. In a static sense, this clearly isn't the place anymore where one would go naturally to produce a low-end product at the cheapest price. So that reality, I think, is relatively indisputable, but the way it's been interpreted is quite varied. And let me just give you two general examples of the way this end of cheap China story is interpreted. One, in China, by at least parts of the Chinese government. I think the attitude is that China has become already quite focused on low-end manufacturing, but this is a problem, because already there's competition from places like Vietnam and competition from places like Bangladesh and Pakistan. Lots of places can do low-end manufacturing. So the question for China, at least that some in the government are asking, is, well, what's next? How do we possibly upgrade? And how can Chinese growth be sustained unless somehow this becomes an innovation-centric economy? So the assumption there, and I certainly hear this in the Ministry of Science and Technology, is that China is a manufacturing economy, but it's not an innovation economy. And then the question is how to make that next jump, that next leap. And there are a number of different solutions. So to some extent in recent years in the Ministry of Science and Technology, there's been the big push for 自主创新, indigenous innovation. Do the innovation here. Reproduce the technology here. And I won't comment directly about that view right now. It's not the only one in China, but it's an important view that's out there. Now let me mention a very different view, one quite prevalent in my own country, in the United States. And that view says China has become a center of manufacturing. That means it must also be a center for innovation. And somehow, that combination of manufacturing and innovation is coming at America's expense. They, the Chinese, are taking all this manufacturing. Manufacturing is very intimately linked to innovation. Innovation is leaving the United States, and we, Americans, we need to do something about it. So my president, Barack Obama, has announced a new manufacturing initiative, and the idea there, which again I won't directly comment on, is bring manufacturing back. And why bring it back? Well, job creation, very important, but frankly, it's innovation creation, that you need to bring the manufacturing back to stimulate innovation. Well, that's very interesting. It's quite a different view from what we see in China. So what I'm here to at least suggest is neither of those views, they're not crazy, they're not totally wrong, but I don't think they really get to the heart of the matter. So in my view, based on some research that's going on and research that's been informed by a number of Swiss companies, my view is that innovation and manufacturing, or I should say upstream R&D and manufacturing, are intimately linked in a variety of multi-directional ways. They're intimately linked, no doubt about that. However, they need not be geographically linked. This linkage might happen over vast geographic distances. What interests me about the China story and the story of China's growth is I think a particular kind of upgrading is happening here. And it's in fact already happened. There's not just manufacturing that's somehow separated from upstream R&D. Instead, there is a unique kind of innovative manufacturing that's happening. Not manufacturing that's linked somehow just to different, to innovation outside, but innovative manufacturing. What do I mean by that? Well, at one level, innovative manufacturing, in my view, involves, at least as it happens in China, the simultaneous management of three, I guess you can call them variables: tempo, scale, or scaling, and cost. So China, in many different sectors as a geography, isn't the cheapest place to do many activities, but it is the place where you can scale extremely rapidly, all while moving down the cost curve. So in a number of industries, what's most important is not being the cheapest in a static sense, but what's most important is getting up to scale quickly and doing it while pulling out costs in order to hit a particular market window, but not necessarily doing it the cheapest globally. So let me say a little bit more about what I think innovative manufacturing is, and then I'll just give you some examples or a little bit of a taxonomy, and then I'll stop. So I mentioned this idea of simultaneously managing tempo and scale and cost reduction. For me, what that means is, or what that involves is, number one, a high degree of engineering expertise. So this isn't a story about low wages or low-skilled or even medium-skilled labor. It's largely a story about engineering skill and product development skill that is able to link upstream R&D, much of which happens outside of China, although increasingly it's happening inside China. But this engineering skill is able to link upstream R&D to a fabrication process. And often this engineering talent involves detailed design. It involves design for manufacturability. It involves knowledge about managing an extremely dense and varied supply chain, but it's multi-dimensional. So engineering intensive, and skill intensive, which has to do with a series of changes in the Chinese educational system. Second piece of this innovative manufacturing story, it involves the idea that this is happening not just in mature technology areas. Indeed, it's happening in areas involving new-to-the-world technology. So certain kinds of technologies that have never really appeared anywhere else in the world are being commercialized for the first time globally, and they're happening in China because there's knowledge not so much about upstream R&D, but there's knowledge about how to translate this R&D into a product from which one can extract value. Now, at MIT, where I've spent the last 17 years on and off, except when I'm in China, at MIT there's a lot of emphasis on creating new-to-the-world products, on innovating, which is great and appropriate. I think there's less emphasis on product development, less emphasis on design for manufacturability. It's not ignored, but just not quite emphasized as much. Less emphasis on scaling a production process. But if you invent something new, whether it's a technology, a service, you can't extract value from it until you demonstrate it and produce it and scale it up and market it. In many respects, the innovative manufacturing that's happening here has become a critical enabler for the upstream stuff that's happening elsewhere, for new technologies, not just mature technologies. Third piece of this, third characteristic is that the learning, the communication that goes on between innovative manufacturers based in China and upstream R&D specialists outside China is increasingly multi-directional. So we're not in the world anymore of just technology transfer from Switzerland or Germany or France or Japan or the United States, technology transfer to China. We're in a world in which highly specialized players are communicating and learning multidirectionally. And I think the most successful of those players in China, in Switzerland, in the US or Germany, they understand that and are here in China and working abroad with an open mind and a willingness to learn. If they're involved in upstream R&D, they're going to learn something about manufacturing with their partners or their subsidiaries here in China and will internalize that. So there's a multi-directional learning component. And just lastly, there's clearly an international dimension. Chinese innovative manufacturing is very rarely about a purely, wholly indigenous process, which I think is good, actually. And I'd be willing to argue that the wholly indigenized technology development processes in China aren't the ones where the most exciting innovation happens. And I would be willing to argue the same, by the way, for the other country I spend a lot of time in, the United States, that the wholly indigenized technology development processes are less exciting, less rapid, less cost-effective than some of the more globalized processes, many of which involve China. So I've been speaking in the abstract. Let me try to bring this down to the level of a few examples. I'll walk through a little bit of a taxonomy and see whether that adds a little bit of clarity. So in my work and some of the work that my graduate students are doing, we've tried to define sort of 4 variants of this innovative manufacturing style that involves Chinese counterparts, and Chinese partners, Chinese subsidiaries in some cases. The first example is one that I think is pretty familiar to most people in the room. It's, I guess we term it reengineering or reverse engineering, where there's a mature product, a mature technology, an existing technology. It's perhaps already been sold extensively in North America or Western Europe, but in the China business ecosystem, there are people, often Chinese companies, who are able to take this existing product, this existing technology, and they're able to reproduce it much cheaper. So, you know, there are a lot of terms you could use to describe that behavior. Again, in the United States, piracy is a popular term, and not a very polite one. But what I'd like to argue is that I'm not a lawyer, I'm not a trade, I have nothing really, I have no knowledge about the law, and I don't really want to make a judgment. What I want to argue is that this capability to re-engineer involves much more than copying or imitation. And in fact, you see that when you see companies, when I see a Swiss company or an American company that's doing this re-engineering process or coming to China to access this re-engineering process in order to come out with new products which will command value. So let me explain a little bit more. I do a bunch of work in renewable energy, with renewable energy technology. So in the wind turbine business, when the market was growing here very rapidly, starting in around 2006, but in years after, a number of global players, we could all name the names, came to China. And initially, or quite soon after the market developed, many of the global players, I can't really name any names, but again, you could figure them out, discovered what they felt were copies of their turbines were appearing in the Chinese market by indigenous companies. And there was a lot of resentment about that initially. I've worked with some of these companies, some of the foreign companies and also some of the Chinese companies. So there was a lot of resentment initially about these ostensible imitations that were out there. At least one of the global companies I work with, because of, I think, a rather open-minded country director, purchased a number of those ostensible copies. And what they found was very interesting. They found that, and this is a totally typical story, I'm sure many of you have had this experience, what they found was that the copy wasn't exactly a copy. And that in fact, what their competitors had done was they had taken a product, they had identified pieces of that product that were over-engineered, in some sense for the Chinese market. They identified certain componentry that could be swapped out for much cheaper componentry, particularly componentry that was available, readily available in the Chinese supply chain, in a very dense supply chain here. They identified certain performance attributes that could be, how shall we say, removed from the product because they weren't particularly appealing to a Chinese customer. So we can have an argument, and maybe we should have an argument about whether there's piracy involved. But what's for sure involved is there was a tremendous amount of engineering expertise that was required to re-engineer that product, pull cost out of it, make it more easily manufacturable, and make it performance-wise suitable to the demands of a customer here. So I mentioned that case, again, not to push the piracy issue because that's really a separate topic. I mentioned that case because this particular multinational firm that saw that happen, their reaction, aside from expressing anger initially, was to try to internalize the lessons of that re-engineering and pull it back into their own products. It's very smart. Try to duplicate the supply chain, which they saw here. As soon as they did that, they found that their supply chain that had been partly based in North America and Europe, those suppliers who claimed that they were operating right at the thinnest margins, couldn't possibly give anything else, cut their prices by 20 to 25% right off the bat when they were checking. So, that's very interesting. Very interesting what that simple threat to move the supply chain to China did. Second thing they realized was that, their competitor's product which was decosted and the quality was a little lower, it was coming in at about almost 25% cheaper, or less expensive, I should say. That's an important lesson. So this multinational, again, tried to internalize it. What they weren't able to do, for a variety of reasons we don't really need to go in, they couldn't match the tempo of a number of their local, their indigenous competitors. They couldn't match the organizational tempo of this reengineering effort, this reconstitution of the supply chain, this ability to get a product out quickly. Now, there are many other examples of companies, some European, some American as well, that have internalized this lesson of reengineering through their operations in China, through their subsidiaries in China, where a product that was perhaps selling well in Europe or North America but declined, they tried to reorient it to China, but it needs to be re-engineered. But the re-engineering effort that happens in China makes that product quite accessible and appealing to a global mid-level market. Very interesting, and I would argue extremely innovative. Not, how shall we say, sexy innovation from kind of a Silicon Valley, new-to-the-world product, or even an MIT sense. Not sexy, but in fact incredibly lucrative and incredibly important. And, by the way, it creates jobs, because it creates new markets, or at least satisfies existing markets for which products weren't, global markets for which products weren't being produced. Okay, so the re-engineering story, not to be dismissed as just imitation. Second thing, second interesting, I think, variant of this innovative manufacturing is the idea that a China-based manufacturer, maybe Chinese-owned, maybe foreign-owned, maybe ambiguously owned, can say to a design house, maybe one in Germany, maybe one in Switzerland, maybe one in the US, say a turbine designer, could say to them, we can make your designs come true, or we can bring your designs to life. Maybe you know a tremendous amount about design, but you don't know how to set up a supply chain. Or maybe you don't know a great deal about design for manufacturability, but we do, and we'll partner with you. And so I can give you many, many examples of these kinds of partnerships, some of which are done on a licensing basis, some of which are done a little bit more informally and relationally, but many examples of actually iterated partnerships in which effectively a fabless design house, but in a number of industries, but in this case in wind turbines, will partner with a Chinese manufacturer and will have designs that the European or North American designer couldn't figure out exactly how to produce in a cost-effective fashion, and the Chinese partner was able to do it. And there was a reasonably trust-based relationship that developed over time and has persisted. Let me give you a third one and then a fourth, and then I'll stop. So there's the sort of, we can bring your design to life. There's a third example that I think is quite interesting. Not so much we can bring your existing design to life, but we can take your scientific principle that's never really resulted in a product to this point, and we can help you demonstrate that principle at scale. We can bring new-to-the-world technologies into through a commercialization process. Let me give you a quick example. I work with a company, I won't say where it's based because I should probably keep this confidential, though it's been in the news plenty. So this is a small company, a startup that has a process for coal gasification. Very interesting process, very promising. It's been demonstrated at the lab. It's been demonstrated not at scale, nowhere close to scale actually, but looks very promising. There was no way that company was going to get financed in Europe or the United States. The amount of money required to demonstrate this technology at scale is vast, because it has to be demonstrated either in a power plant or a fertilizer plant or a refinery. So the technology, like many others of this kind of category, low volume product but big scale, hit a pretty traditional valley of death, and the company was going to die. But a number of Chinese investors came in, and what they were bringing with them was not just money. Money's important, undoubtedly, but they were bringing two other things that were very important. They were bringing knowledge about scaling manufacturing. So they were able to, and are in the process of taking this process demonstrated in a lab, and are able and have been able to some extent to come up with a design for manufacturability which has substantially reduced the balance of plant costs for this project. Again, very typical story. We see it in conventional thermal power generation, we see it in civilian nuclear, but the key technologies are, or the critical core technologies aren't the question. The real question is, how do you cut out balance of plant costs? And a number of Chinese partners have been able to do this. The second thing they brought is a market that's demanding this technology. So right now, because of the gas situation in North America, coal gasification is not particularly economically feasible at the moment. In China, however, it's a different story. So you have a technology that's yet to be commercially demonstrated at scale, but you have off-takers for the product, gas already lined up, ready to go. So a very different environment, but enabling innovation, in this case in the United States, that would have died. Same thing, by the way, for the previous example of we make your designs come true. I can give you a number of examples of battery companies that were taking their new designs, very R&D intensive designs, bringing them to China and finding the costs coming out continuously over the years. So just the last example, and I think maybe the most interesting one, and that involves China as an ecosystem and Chinese partners becoming platforms, technology platforms for new technology development. And the example there I would give has to do with what, for Americans, at least also Europeans, is a very politically contentious industry right now, photovoltaics. So lots of trade battles. We all know about those. I won't really go into them. But despite the tough politics about this industry and the trade battles about this industry, it's quite remarkable to me the extent to which China-based manufacturers, which as you all know have grown very, very rapidly, there's probably going to be there is a big shakeout going on in that industry, but it's interesting to me the extent to which these China-based manufacturers have become critical partners, in this case, in my own experience, for American innovators, far upstream, R&D intensive innovators, particularly in new materials. So here's a quick example, then I'll stop. And this is a well-publicized example. There was an American startup that came out of Silicon Valley, came out of the semiconductor industry. It was a startup called Innovolite. I don't know whether any of you have worked with Innovolite or were familiar with Innovolite. It was kind of like things you see also at MIT, but Innovolite was started by a series of engineers who developed a liquid nanomaterial. Very interesting material. It's a selective emitter, so it had potential applications in a number of different industries, solar PV, flat panel displays, a number of different industries where this nanomaterial could have been used, but the inventors of this material, they're not production people, they're not manufacturing people, although they aspired to be, but they had this material. You know, you could hold it in a small flask. They had dreams of getting into the PV business, but they had a couple of problems. They worked with NREL, the National Renewable Energy Lab in the United States, US government lab, to demonstrate that this material, when applied to a solar cell, could improve the efficiency of the cell quite dramatically. However, nobody at NREL specializes in scaled manufacturing. That's not what they do, and nobody at Innovolite, if I may say so myself, really had any experience in manufacturing. But they went to the VC community and wanted money to build a fab in California. Well, maybe not surprisingly, although we can argue whether it's just or unjust, nobody was willing to give them the money. And the company nearly died. But then they pursued a different strategy. Instead, they came to China, and they elected to try to work with a series of PV producers here, actually in Shanghai. Their first partner was JA Solar at Jing'an, here in Shanghai. Now, the Chinese partners, on the one hand, weren't terribly eager to work with Innovolite. Why not? Well, you know, the Chinese PV manufacturers are competing intensely with each other. They're an intensely competitive industry, and their attitude was, you know, you have this nanomaterial, you've shown with NREL that you can improve the efficiency of one cell. But, you know, we're in the business of mass production. You don't know how to apply this material to cells in a mass production environment. We probably know, but we're going to have to see. We're going to have to co-develop this technology with you. And if we co-develop this with you, as soon as we demonstrate that this material is applicable, you're going to run off to our competitors. and we'll have paid your development costs and you'll run off to competitors. So very interesting, Innovolite had trouble developing a trust-based relationship, not because they weren't trusting the Chinese weren't trusting them. In any case, over time, they were able to develop this relationship. JA was the lead user, but JA wasn't just the lead customer, it co-developed that technology. So Innovolite engineers were on JA's shop floor, on their fab floor, and there was a tremendous amount of going back and forth, a lot of airplane rides between California and Shanghai. It was easy to some extent, the relationship, because JA is managed to a large extent by returnees who can keep the bridges maintained quite easily. But the punchline of the story is that here you had an American startup that was about to go under. It partnered with a Chinese manufacturer. The Chinese manufacturer, because it understood manufacturing, co-developed the technology very effectively for the Chinese firm. It gave it a brief competitive advantage in a very tight industry. Innovolite didn't go under. It was acquired by DuPont at a very appealing price. The founders of Innovolite did very well. In fact, most of them are still working at DuPont. DuPont has become, again, a tough industry right now. DuPont has become a leading supplier to the global PV industry, a leading high-end component supplier. And I guess you could say that in PV, at least, the technology development system, the system for innovation, is a global innovation system. If you pull China out of that system for a company like DuPont or another American company like Applied Materials, for these kinds of companies, their entire customer base, virtually their entire customer base, is in China. And those customers aren't just customers, they're co-developers of technology. There's a disconnect between that reality of a global ecosystem and the political discourse, partly here in China, of indigenous innovation, and also in the United States of bringing manufacturing back. And I think it's sort of incumbent upon a number of us who are involved somehow in that discussion to come up with a better answer than what the government seemed to be coming up with today.